Understanding and Comparing Distributions, Chapter 5. A recent survey of North American males found 42% were overweight, 34% were critically obese, and 8% ate the survey, from Banksy. Objective 1.5. The student will summarize distributions of data measuring the position using quartiles, percentiles, and standardized scores. 1.11. The student will compare distributions of data with respect to their shapes. Chapter 5. What you should have learned about. The big picture, box plots of 5-number summaries, comparing groups with histograms, comparing groups with box plots, outliers, time plots, and looking into the future. We're expressing data, a first look, just checking. What can go wrong? Alright, these are the videos after reading the book. The big picture. Let's start with the big picture. Here's a histogram and 5-number summary of the average wind speed for every day in 1989. Because of the skewness, we'll report the median and IQR. We can see that the distributions of average wind speed is unimodal and skewed to the right. Median daily wind speed is about 1.90 miles per hour, and on half of the days, the average wind speed is between 1.15 and 2.93 miles per hour. We also see a rather windy 8.67 miles per hour day. Was that unusually windy, or just the windiest day of the year? To answer that, we'll need to work with the summaries a bit more. Box plot and 5-number summaries. We need a quantitative variables for a 5-number summary. We can display a box plot for a 5-number summary. Continue. Finding an outlier. IQR equals Q3 minus Q1. Lower quartile. Q1, 1.5 IQR. Upper outlier. Q3 plus 1.5 IQR. Steps to drawing a box plot. Draw a single vertical axis spanning the extent of the data. Draw short horizontal lines for Q1, Q3, and median. Connect them as a box. Draw dots for minimum and maximum. Use a line to connect Q1 and minimum. Use a line to connect the maximum and Q3. Make a dot for the outlier not connecting them. The formula for finding outliers is above. Comparing groups with histograms. We compare groups because it makes data more interesting. Use 2 histograms with the same scale. Comparing the same topic among the 2 groups, for example, average wind speed, spring, summer, and fall, winter. Describe the shape, center, and spread of the groups. Unimodal, bimodal, skewed to the left or right. Use the mean or median for the center and state what it is, the range, any outliers, etc. Can use a table to record summaries of both histograms. Comparing groups with box plots. When using a box plot, it is a lot easier to look at more than 1 or 2 distributions. When you place a box plot side by side, you can easily see which groups have higher medians, which have the greater IQRs, where the central 50% of the data is located in each group, and which have the greater overall range. When using box plots that are in order, you can get a general idea of patterns in both the center and the spreads. We can see past any outliers in making these comparisons because they've been displayed separately. Outliers. Outliers are cases that stand out from the rest of the data and they deserve our attention. An outlier is a value that does not fit with the rest of the data, but how different should the outlier be treated especially is a judgment call. Although the box plot provide a rule to highlight these unusual points, the rules does not tell you what to do with them. What should we do with the outliers? First, try to understand them in the context of the data. Start with the histogram. Histograms show details about a distribution that a box plot cannot. They give a better idea of how the outliers fits or does not fit. When you have spotted an outlier, you must tell about it. You do this by summarizing the data without the outlier. 2 things you should never do with the outliers. 1. Leave an outlier in place and proceed as if nothing were unusual. 2. Drop an outlier from the analysis without comment just because it's unusual. Time plots and looking into the future. Time plots are sometimes a display of values against time. The overall pattern and changes in variation are displayed in time plots. It is riskier to extend into the future when using a time plot. We're expressing data, a first look. We're expressing to improve symmetry. When data are skewed, it can be hard to summarize with the center and spread and to determine outliers. Solution. Re-express, transform data. Apply a simples function to make the skewed distribution more symmetric, like taking square roots or logarithms, log of 10 of x. Re-expressing to equalize spread across groups can help alleviate the problems of comparing groups that have very different spreads. For example, for values that can't be negative and whose distribution are skewed to high ends, logarithms would be good to use. Alright, just checking. What can go wrong? Avoid inconsistent scales. No changing scale in the middle of the plotting. Label clearly. Be aware of outliers and make sure you always check for outliers. Chapter 5 homework. Long-term review. Box plots. When using a box plot, remember how they are separated. Each quartile has 25% of the data. Also, the box plot is set up by a distribution that is called a 5-number summary. Minimum, first quartile, median, third quartile, and maximum. Time plots. When setting up a time plot, remember to never risk taking a guess of what may happen in the future unless you have strong reason for doing otherwise. As you move on to having more knowledge of statistics, you will soon understand when, how, and how much we can justify doing that.